In this video, we're going to look at summing the terms of a sequence, specifically in summation notation. So the terms of a sequence can be denoted with this summation notation, which is the Greek letter sigma. So this is sigma. So when we see the Greek letter sigma in math, we think automatically summation. So we're going to add up. And then underneath the sigma notation, you're going to have some variable equal to a number, and this is your starting position. So what position in the sequence do we want to start adding up the terms? And then above the sigma notation, you're going to have another value or variable, which will be your stopping position. And then after the sigma notation, you're going to have an explicit formula for a sequence. So this formula here would be the formula that we're going to use to generate the actual terms that we will then add up. So let's look at some examples here. This one says find the summation of k equals 1 to 5 using this sequence 3k. So what this means is that we are going to start with k equals 1 and we're going to plug 1 in for k. So we're going to go 3 times 1 plus, and then we're going to do k equals 2. So we're going to go 3 times 2. Plus, and then we're going to go k equals 3, so 3 times 3. Then we're going to go k equals 4, so 3 times 4. Next, we're going to go k equals 5, so 3 times 5. Now I'm going to stop because my term on my top was 5, so I went from the first term to the fifth term. So now we just need to do the arithmetic here. So this is just 3 plus 6 plus 9 plus 12 plus 15. And then we just need to add that up, and this gives us 45. Most of your calculators should have the sigma notation on it. So if you go to your calculator, press your math button, and then on the math menu, you just want to go down towards the bottom, and you should see summation with the little sigma. So on mine it's 0. So I'm going to choose that summation, and then you're going to get your summation notation there. So you have to choose a variable. I would just use x because it's easy, so you can just use this button here next to alpha and just go x equals 1 to 5, and then put in your explicit formula. You have to use the same variable you used underneath. So since we used x, we're going to use x instead of k here. So we're going to go 3 times x. And then just press enter and it will evaluate that for you. So it's kind of a little time saver for you. All right, so let's take a look at this next one. So this next one says we're going to evaluate the summation of k equals 5 to 8 of k squared. So here we're not starting at the first term, we're starting at the fifth term. So we're going to plug in 5 for k. So this is 5 squared, and then 6 squared, and then 7 squared, and then 8 squared, and now I know that I'm going to stop because 8 was the stopping position. So again, then we're just going to do the arithmetic. So 25 plus 36 plus 49 plus 64, and that gives me 174. Again, I can use the calculator and do the summation notation in the calculator. So remember math button, and then I want to go down towards the bottom so you can use the up arrow because it's a little bit quicker. And then again, I'm going to use x, so x equals 5 to 8, and then we're just going to go x squared. One more example here. We're doing summation from n equals 1 to infinity of n minus n to the nth power. So this one we're summing to infinity. It's called an infinite summation, so we have to sort of look and see if there's some sort of pattern involved. So if I plug in 1 for n, I'm going to get 1 minus 1 to the first power. And I'm plug 2 in for n, so 2 minus 2 to the second power, and then 3 in for n, so 3 minus 3 to the third power. Then I'm going to do 4, so 4 minus 4 to the fourth power, and I'm going to do that forever. So we need to look and see if there's some sort of pattern forming. So this is going to give me 1 minus 1, 0 to the first power, plus 0 to the second power, plus 0 to the third power, plus 0 to the fourth power, forever. So 0 to any power I know is 0, so I just have 0 plus 0 plus 0 plus 0, etc. forever. But I know if I add 0 to itself forever, I'm still going to get 0. So my summation is actually 0. If I wanted to use the calculator, what I could do is go and get the summation notation, and I could see what kind of pattern forms. So maybe I'll go like x equals 1 to 100, of, now be careful here that you need to put everything of the explicit formula into these parentheses. So I'm going to do extra parentheses and go x minus x to the x power. So I want to make sure it was all inside the parentheses for the explicit formula. So I calculate that and I get 0. So maybe I'll try that again and just change my number for my stopping position and make this 1,000. And again, I get 0. So you could try a couple more if you wanted, but you can see from the pattern that we will get 0 no matter how many times we do this.